Hello students, welcome to exam list. So before going into Euler's equation, I want you to understand this particular formula in great detail. Okay, so to understand this, let me first define something. This P here is the pressure held or the pressure experienced by the block. Pressure experienced by ball of liquid. Okay, so this P is the pressure experienced by the ball of liquid. However, this P here is the distribution of pressure, or I can say it is the pressure field. Okay, now distribution of pressure or the pressure field is what is the property of liquid. Okay, so it depends on how the pressure is distributed when an obstacle is placed in front of the flow of the liquid. So liquid was flowing and this was the obstacle, and I have marked here the pressure, the locations of high pressure and low pressure. It means when you place an obstacle in front of the liquid, the pressure is distributed, okay, along the different points, and each point has different pressure. So I can define pressure P as a function of space points x, y, and z. Okay, so it should be better if I use this symbol, because this symbol indicates that this P here is the field operator. Okay, now what is this P here? This P here is the pressure held by the ball of liquid. It is the P that is experienced by the ball of liquid. It is not the P pressure distribution. Now to get a feeling, I thought of making this particular analogy. You remember wave equation? It tells you that d square y divided by dt square equals, so we have 1 by v square here, equals d square y divided by dx square. Okay, so let me make this a bit interesting. We know that v is constant, so I can write d square y divided by dt square is proportional to d square y divided by dx square. Now let's try to understand. What is dy by dx? We know that dy by dt, oh, what is dy by dt? Dy by dt is the velocity of each particular oscillator. So if I have a particular oscillator here, it is moving up with a particular velocity. This velocity is equal to dy divided by dt. You see that this velocity is a function of space and time, because it depends on which oscillator are you considering. If you are considering this oscillator at a particular space and at a particular time, the velocity will be different. If you're considering this oscillator at a particular space and a particular time, the velocity will be different. But the overall idea is dy by dt represents the velocity of an oscillator on the rope. Okay, we have discussed this equation clearly in our wave and oscillation lecture series, so please go through this before going through this lecture. Okay, so dy by dt is something that individual particle holds. So what does it indicate? it is the velocity of the individual oscillator in the rope. Now if you focus on this term dy by dx, or if you focus on the square of this d square y by dx square, this is a representation of distribution of different displacements with respect to x. So remember, this is the x direction and this is the y direction. Now y as a function of t, x as a function of x, represents how the y value changes with respect to x. So you can say that y as a function of x here represents the distribution of y function with respect to position x. So what information does d square y by dx square hold in it? It holds the distribution of y values with respect to x. Okay, this is what the information it holds. Obviously it holds some information, not exactly distribution of y with respect to x, but double derivative of distribution of y with respect to x. That means on the left hand side, this y, I mean this d square y by dt square, it has something to do with the individual oscillator present on the rope, and this side d square y by dx square has to do with the distribution of y along the rope as the wave is traveling. Okay, so I can say that the right hand side has the information about y as a function of x, that and its derivative with respect to x, that is, it has the information about the second derivative of distribution of y with respect to x. And on the left hand side, if you can see, it is nothing but acceleration of each individual oscillator at a particular x and a particular time. Similarly, the thing is same here. Here the left hand side carried the information about the individual particle. Similarly, in this case also, the left hand side, I mean dp by dt, carries the information about the pressure experienced by this ball of liquid. As the ball moves here, after a particular time it will experience pressure, it comes here. So it's all about what pressure the ball is experiencing, which is written in terms of the distribution of pressure and velocity in the fluid. Here V represents the velocity distribution in the fluid, or I can say the velocity field, and here this P represents the pressure distribution as a function of space coordinate in the fluid. So we represented the pressure with respect to the ball of liquid and the pressure that is distributed with in the fluid. Okay, I hope you get an understanding of this particular idea, because we are going to use this in understanding the Euler's equation.